We are going to discuss Lagrange equation of motion for elevator. We shall include passenger's weight. This is typical picture of lift elevator. We shall assume let elevator mass be small m, passenger's mass be capital M, and displacement be along vertical axis y. Gravitational acceleration is g, and lift force provided by motor is f of t. There are two types of forces: upward force f of t, total weight of system m plus capital M into g, and acceleration along y-axis. Kinetic energy of system is 1 by 2 m plus capital M y dot square, where y dot is velocity along y-axis, and m plus m is total mass of the system. Potential energy is m plus capital M into gy. Lagrangian is kinetic energy minus potential energy, that is 1 by 2 m plus capital M y dot square minus m plus capital M gy. Lagrangian equation of motion is d over dt of partial L over partial y dot minus partial L over partial y equal source term qy. We can observe that in Lagrangian equation there are two types of terms, one velocity terms and other position terms. Taking time derivative of Lagrangian and with respect to y dot and y. When we take derivative with respect to y dot, we get 1 by 2 m plus m into 2 y dot minus 0, which is m plus m capital into y dot. Now take derivative with respect to y, we get 1 by 2 m plus m 2y prime into 0 minus m plus capital M g into 1, which is minus m plus capital M into g. Putting values of partial L over partial y prime and partial L over partial y in the Lagrange equation. In this equation, putting values of partial L over partial y dot and partial L over partial y and putting q of y equal f of t, we get m plus capital M y double dot equal f of t minus m plus capital M into g. Simplifying, we get y double prime equal f of t over m plus capital M minus g. Here ay is acceleration along y-axis, which depends on mass of the system and force applied by the motor, which is f of t. Here g is acceleration due to gravity, which is constant here. There are three types of conditions. For upward motion, weight of the system must be greater than gravitational acceleration g. Weight of the system must be less than the applied force by the motor. For upward motion, applied force must be greater than weight of the system, that is f of t must be greater than m plus capital M into g. For downward motion, the force applied by the motor must be less than weight of the system, that is m plus capital M into g. There is a third condition, constant speed or equilibrium condition. This condition prevails during goal motion of the elevator system.